world. We have come again as usual to give you the real life questions. This exam you are going to write the life questions. We are here with them watching this as the questions. We're handling them. Carefully see them. You have it here. And then after this, we handle the practical itself. The practical, we proceed. Then the teacher's guide on how to do your report for your students. Okay, so remember to just ask your questions. These questions are they are here real life. We give you that. Okay, thank you guys. Don't miss this opportunity. Then we have over here we have our salt analysis as we predicted them. So you come down. So we handle them for teachers. This is the report form on how to fill it. I used that of last year to teach you how to fill the practical report form. All right. So remember to subscribe and share this video. You are on. If you are on, your job is to give this video thumbs up. Right. Yeah, I can see you. I can. Thank you, Ngozi Ede. I can see you guys. Let's maximize this opportunity very, very well. And we are here for you live. Your job is just to subscribe and share this video. This live stream will cover for both students and teachers. For students, it will teach you this, so will solve these questions exactly for you, give you the shortcut and detailed explanation. For teachers, we teach you how to fill your practical report. All right. So we are here live. Remember to ask your genuine questions, both the SALT analysis and also the real experiments will be happening here today. So after solving this, we will also go to the laboratory and show you the practical itself. All right. So let's see this question here. This question says that, I hope it's visible. All right. Thank you for liking. I can share, please. Remember to follow the instructions in on your question paper. All your burette readings, initial and final, as well as the size of your pipette, must be recorded, but no account of experimental procedure is required. All calculations must be done in this booklet. So most people don't even have time to look at this instruction. Please, it's not all about, you have seen this question now. You will answer. If you don't follow the rules, you will not get it correct. All right. So the major thing here is you have to record the volume of pipette used. This minor thing gives you marks. So they say A is a solution containing 5.75 gram of impure tetraoxosulfate 6 acid per 500 cm cube. And B is a solution containing 1.0 gram of sodium hydroxide per 250 cm cube of solution. Put A into the burette and titrate against 20 or 25 cm cube portions of B in a conical flask using methyl orange as indicator. Repeat the titration and to obtain concordant titers. Tabulate your burette readings and then also determine the average volume of A used. Equation of the reaction. We will be making our table with this within this space. Okay, but before then, I want us to also quickly see other possibilities. We will solve many of these questions. Remember that you are live with Sir Majesty Easy World Science channel. Please subscribe and share this video to help others. Then over here, we'll look at the salt analysis also. These are the things we are expected to do in our salt analysis. You will learn a lot just for tuning in to this live stream. Okay, so please Immediately you see this link, you share it and let others also benefit. Now, the follow-up question for that titration I asked you, this one is report form for teachers. So if you're a chemistry teacher, you are covered. I'll teach you how to go about your report form. This is trying to tell you that I will also show you the experiment itself. The titration, you will see it here. The salt analysis, you see here. I couldn't snap that page, and this is the follow-up question for that the other one. I say, they say from the result, we are packaging this very fast. They say from the result and information provided, calculate the concentration of B in mole per dm cube, then concentration of A in mole per dm cube, and concentration of pure A in gram per dm cube, percentage purity of the acid used, and also the relative density of the acid used, the dilute acid. So we'll be solving these follow-up questions. All right. So I will go to my solve page. Remember, look at the question we are handling. This is the question guide. I hope that if you are live, you will see you are seeing the screen fully well. All right. Here we move. So look at the question. If you are to do this, we first of all make our table. But to save time, the table, I will be writing direct on this as you are expected to do on that day. Remember to read the questions on the question paper. When I finish this solving, and then we enter into the salt analysis, remember watch all of my videos on the likely questions, how to prepare the standard solutions for chemistry teachers. So I want to make my table. I will use remember to ask your questions. I can see every message you are sending. I will attend to you when I now start solving. Okay. Make your table for burette reading. Remember, avoid cancelling table. You have your rough. You have your first, second, and third titles. Okay. So here is our burette reading. The line is already there, but please tabulate it. Don't use a rough table. Okay. Remember to record. This is a revision class giving you a clue of what you're expecting on that day. So if you listen well, you will learn a lot. Okay. So we have, this is it. So we can clean up the excess. Remember, the live stream will cover this theoretical guide and also give you the practical guide itself. Maybe I'll try using blue. So remember, they told you to indicate. You have to write volume of pipette used. Very important. I will be using 25.00 cm cube here. If you have watched my my videos in the past, I've done this experiment. So here will be my burette readings. Then you write here rough, first, second, and third. Then here is the final. You put the unit in cm cube. Here is initial in cm cube, and here is the volume of A used, also in cm cube. You indicate it. Now, because I've done this titration, I've seen the rough. In my titration for today, I got 13.40. Remember to leave your table in 2 decimal places. Okay, so Then you have to minus your final from your initial from your final. 0.00 minus 13.40. I mean, never you write 13.4. You must complete it by writing 13.40. That is what we mean by two decimal places. Please listen very well. This live stream is to help you to avoid making silly mistakes, okay? So we have our 13.40 also. My first title 11.90. I want to make everything 0.00. 11.90 is 12.10, 0.00, 12.10. Then the last is 12.00 and 0.00. This is also 12.00. This is the order with which you have to fill the table accurately, okay? So that you don't make what? Mistakes. The volume of pipette gives you mark. Don't cancel this table. You see how neat this table is? That is the instruction. There will be a mark for you. Remember, I wrote this here for telling you what we mean by. Then, the first question says, put A in a burette, tabulate your burette readings and determine the average volume of A used. I've tabulated my burette reading. So what will be my average volume of A? That is, tell the examiner average volume of A, bracket, to tell the examiner the one you are using. If you look at first, second are concordant. All right, we are back. Sorry. All right, we are back. Sorry for the interruption. First plus second plus third, divide by 3. If you are using 3 figures, you divide by 3. If you use 2 concordant titles, you divide by 2. It is a way to do average. So this implies that my first is 11 plus 12.10 plus 12.00, all divide by 3. Remember that these figures I'm using here, you are not going to use. It depends on the endpoints your school is using. So you cooperate with your school teacher, your school do the titration. I am using, don't go and say that you saw one man online using 11 and you went ahead and used that. No, it depends on what your teacher will report, as I will show in this report form. All right. So we move on and say, if you sum up all these things, this is automatically 36. Yes. So this is 36 divided by 3, and 36 divided by 3 will give you 12.00 cm cube. All right. So this is the average volume of A used. Remember to put your unit as always. So we are done with the question A. Okay. Then we will follow up the question B, which will now be, from your information and result provided, calculate the concentration of, I've shown you. So let's go back to that question. I couldn't snap that page, so I have to type it so quick. Okay, look at the follow-up question. So this question, which is the follow-up, from your results and information provided, calculate the concentration of B in mole per dm cube. See what we're going to do here. Simple. I will divide the screen so we can so I'm coming. Okay, right, all right. And then bring my note here. So the concentration, remember the information about A, we have to, in exam, write it somewhere. A said 5.75 gram per 500 cm cube of solution. Then B told us is made up of 1.00 gram NaOH of what? NaOH per 250 cm cube. Remember that this one is impure. Okay, let me make it clearer. Let me just make it clearer. A contains impure. Therefore, this mass is both impurity and pure sample. Impure mass of 5.57 gram per 500 cm cube while B is 1.00 gram NaOH per what? Per 250 cm cube of solution, right? So this information, don't joke with it. That's what we now use to solve this follow-up question. Remember, I told you I'll show you the practical experiment where I practicalize this thing. So if you really want to learn how to conduct this experiment, stay tuned. Please share this live stream. Share it, okay? Share with your friends. It is a free guide so that your tomorrow will be very nice, all right? So now they say concentration of B in mole per dm cube. This is gram per 250. So remember, in concentrations, 1 dm cube is equal to 1000 cm cube. So, and they said in gram, in mole per dm cube, meaning this one is 250 and not 1000. Therefore, you simply say 250 contains 1.00. What will 1000 contain? You cross multiply. It will contain 250x now equal to 1000 times 1.00. So you divide both sides by 250, both sides by 250, cancel, cancel. So you have now that this is 4. 4 times 1 is still 4. So it is now 4 grams per dm cube. That's the mass concentration. Then, but they asked you in mole per dm cube. You find the formula that connects mass concentration with molar concentration. And that formula is mole per dm cube is equal to gram per dm cube all over gram per mole. Remember to have a good handwriting that is very much readable. So gram per mole means molar mass. Gram per dm cube means mass concentration. Now we are looking for mole per dm cube. What is our mass concentration? 4 gram per dm cube. What is our gram per mole? Molar mass. Molar mass of B. And what did B say? B is simply sodium hydroxide. So what's the molar mass of sodium hydroxide? Molar mass of sodium hydroxide is equal to what? Sodium is 23. It was given in the bracket. 23 plus oxygen is 16 plus 1. So the answer is 40. Therefore, concentration of B mole per dm cube is equal to 4 over 40, which will give you 0.100 to keep to maybe 3 significant figure, though it's not up to mole per dm cube. Always put your unit. Answer to question I. Then we go to question II, which says the concentration of A in mole per dm cube. Now, A is 5.57 gram per 500, but they said impure. This impure means you can no more apply this formula to solve because they said is impure. This formula cannot work, even though we know that it is H2SO4. The question said it. If the question in the exam do not mention that it is H2SO4, please do not assume that it is H2SO4. Do you understand me? Please do not assume until the question mentioned it. But this question I'm solving mentioned it automatically. Maybe for those that are joining, we take you through the question we are solving once again. This is the question. This is the table we have made for the titration. Please, if you are live, share this, subscribe to this channel, for we got much for you both in chemistry, physics, and biology practical. So this is the question we are solving, okay? Remember I said impure tetraoxosulfate 6 per 500 cm. So this 5.75 contains both pure and impure. So I cannot use it as the mass concentration because it is the mass concentration of the impure what? Sample. So it becomes not accepted to use that formula here. I want to bring you up to a speed and you see the table I'm using, how to make your table. Make it very neat, no mutilation or cancellation of any form. Remember, if you cancel your table, if I should cancel this table and repeat another one, I will lose 4 marks. So avoid cancelling your table. Okay, make it very, very neat. So we go back and continue our solving. The question that followed this is at the end. We have our sort analysis, the teacher's guide here, and the experiment itself. You are on with Her Majesty Easy World Science channel. Remember, This is a great dealer in science and surgicals. If you want to develop your laboratory, you contact Her Majesty. Use +234 7065 166 217. That is if you want to buy equipment to equip your laboratory, if you want to conduct experiments, if you want also to learn sciences directly, you contact Easy World Science and Surgical Supplies. We are reliable, affordable, and of course, we are majestic. Thank you for those that are live. Let's continue. So, the II said concentration of A in mole per dm cube. I cannot use the formula I used earlier. I've told you why. Because the mass given is impure. Therefore, if this formula cannot work, if this formula cannot work for me to determine concentration, I will use the Carver formula. It is not called Carver anyway, but the formula that will work now is CAVA all over CBVB equals NA over NB. The idea is that if there are impurities in acid, base will only react with the pure acid molecules. If there are impurities in bases, acids will only react with the pure part of the base. It's just like I mixed sulfur and iron filings. If I bring magnets, magnets will only respond to this ion, leaving sulfur. So when we say impure sample, it is made up of the acid and also the impurity. Why am I not answering you? What question do you have, please? You have to ask question based on what I'm teaching you here. Okay? Direct your questions based on what I'm teaching you here. This is our final revision to prepare you well. You don't need to struggle tomorrow in the exam hall. I did not see any of your questions that I did not attend to. You can send it again, please. Somebody is saying, why am I not answering the questions? All right. So give this live stream thumbs up. Now, if you carry out experiment among this impurity here, the base will already react with the acid, leaving the impurity. So we use titration to determine percentage purity of acid and also percentage purity of what? Base. Having done this, we go back. We are looking for Ca. Always make subject of the formula. If you don't make Ca subject of the formula, you will lose mark. So Ca now is equal to, let's go, CbVb times Na, and Na is the mole ratio of the acid. From balanced chemical equation is 1. I will show you from the equation. Divide by Va, that's your endpoint, times Nb, mole ratio of the base is 2. You do it like this in WAEC, you get exactly what? 2 your mark. But if you don't do subject of the formula and start adding it direct, you will lose 2 marks. Okay? Then we now substitute our value. Ca was Cb. Cb is 0.1 times what's Vb? 25. That's the volume of pipette you used. Then times 1 all over the endpoint. You put your endpoint here. My own endpoint is 12.00. Then times 2. So that we have 0.1 times 25 is automatically 2.5 divided by 24. So 2.5 divided by 24, we go to the calculator and see what it will give us. 2.4, you say 2 point what? 2.5 divided by 24. Ask questions relating to this revision we are doing, okay? So I will show both salt analysis and the titration. This live stream will last very well to serve you. Ask questions based on what I'm teaching you. This class is to guide you. Okay? This class is to guide you. Stop asking me, is it real or whatever. If you don't want to learn, you go. If you want to learn, you stay here. This particular question you're seeing will definitely give you a wonderful help when you enter into the examination hall tomorrow. So thank you for tuning in. So our strength, that Ca is now 0.104. Remember to keep 3 significant figures. So we go back. This will give us 0.104 moles per dm cube. And bless you too, Priscilla. So this is our Ca. Don't make it 0.1. three significant figures matters in the way we report our answers. All right, we have gotten it as our final answer. Then we go to I say the concentration of pure A in gram per dm cube. Time has come now for us to know among this mass provided. Remember that it's 5.57 in 500. We will know the actual mass that is for acid. Why? Because base will only react with acid and not with the impurity. Okay, unless if the impurity is an acid, or less the impurity is a base. That's when it will interfere with the endpoint. Let's move on. The next one says concentration of what? To convert cm cube to dm cube, you divide by 1000. If you want to convert, I saw your question, Emmanuel. So if you want to convert cm cube to dm cube, you divide by 1000. Meaning, if I want to convert 10 cm cube to x dm cube, I'll divide this 10 by 1000, which is automatically 1, 2, and 3. Okay, so which is 0.001. If I'm not mistaken, 1, 2, shift 1, 2, and 3. 0.01. Yes. So 10 dm cube is the same thing as 0.01 cm cube. Okay. I'll go back to the table when I finish solving. You still see the table. You don't need to understand the table. It's the table that you got from your titration. By now, you're supposed to have learned how to make your table, which I've been teaching you here at Sa Majesty. So concentration of A in gram per dm cube. This time around, you convert mole per dm cube to gram per dm cube by using the formula molarity, which means mole per dm cube equal to gram per dm cube all over gram per mole. That's over molar mass. You're welcome, Emmanuel. All over molar mass. Now we want to make this the subject of the formula. So gram per dm cube is automatically equal to molarity times what? Molar mass. Now molar mass of what? A. Molar mass of A. Remember that A is H2SO4. What is the molar mass of A? H2SO4. The molar mass is 98. 1 times 2 plus 32 plus 16 times 4 is equal to 98. So what do we do next? Okay, thank you for yeah, you are following up, Chidubem. Thank you. So we go to the next page. Remember to continue. So we have now that we are doing with our II. We now have that our gram per dm cube is equal to 0.104 times 98. So looking at our calculator department, we have just this times 98, which will give us 10.2. 10.2 is enough. We are talking about three significant figures, okay? 10.2. If you want to change from cm cube to dm cube, you divide by 1000, correct? So we have 10.2 what? Gram per dm cube. Now we look at the IV. Says the percentage purity of the acid used. We go back. Remember, the acid contained 5.75 gram per what? 500 cm cube. You be careful here because the volume here is cm cube, but the strength, this is 10, please. The strength here is dm cube. You cannot work with dm cube and work with cm cube at the same time. You have to convert appropriately. Have to convert so that they will be all in cm cube or dm cube. So if 500 were able to hold 5.75, what will 1000 cm cube hold? Remember that 1000 cm cube is equal to 1 dm cube. So you now say 500 cm cube contained 5.75 grams. Whatever 1000 cm cube contains is giving us the standard molarity. Cross multiply, we have 500x is equal to 1000 times 5.75. Divide both sides by 500. Divide both sides by 500. Cancel, cancel. So that we have here is 2. So 2 times 5.75 will give us what? 2 times 5.75. 5.75 times 2 will give us 11.5. So we have that the real one in dm cube is 11.5 gram per dm cube. This is the impure mass. But out of this 11.5 gram per dm cube is only 10.2 that reacted in the titration, which shows that 10.2 gram is the mass for H2SO4. So for us to know the percentage purity, we just take the mass of pure all over mass of impure times 100. Which one is mass of pure? The mass concentration you got from your titration. Okay? So I'll do that for NECO candidates. So what do we have? We have 10 points. Okay, before then, let me write the formula I'm using. Percentage purity is equal to mass of pure, which is the mass conc of pure, all over total mass of impure given times 100 over 1. So if we do this, what do we have? Our mass of pure, I told you, that is the one that participated in the titration, which is now 10.2. You're welcome. When we read one, then divide by 11.5 times 100 over 1. From the calculator, what do we have? 10.2 divided by 11.5. 10.2 divided by 11.5 is 88.7%. 88.7%. So we have 88.7% as the percentage purity answer. Then the next question might look somehow. It says the relative density of the acid used. The relative density of the dilute acid used. Okay. Desmond or Nole, you're welcome. Please focus and learn to ask your questions. So the relative density of the dilute acid this time around simply simple because density is equal to mass over volume. So the relative density, the only thing is that you calculate density the same way you calculate relative density, but you cannot you put a unit in relative density. So is equal to mass over what? Volume. And what's the mass? You are not using the acid, not the impure acid, okay? We are looking at the relative density of the pure acid. So you look at 10.2 gram per dm cube. That simply means 10.2 is the mass divided by the volume, which is 1000, okay? Which will give us, move 1, 2, 3, will give us 0.0102. That's the diluted formula, okay? So we are done with this. Next, we look at the titration question. I mean the experiment itself, or we go to the next possible question. This is the salt analysis, the salt analysis question. But remember, the one we just solved is you are on with Sir Majesty's World Science channel. We are guiding you for the final revision, okay? So remember that you are on with the right source. I help you to pass your science subjects where chemistry, physics, biology. This channel have your back. And again, if you have not watched someone said you don't understand the table, I'm displaying it again, okay? I'm displaying it with reference to the yes, they can ask percentage impurity of the acid. If they ask you percentage impurity, you now find the mass of impurity. You simply, I'm answering Chidubem, please. They can ask you, if they ask you percentage impurity, I like that. What you do is simply minus the mass of pure from the impure, which means 10.2. That's 11.5 minus 10.2 over 11.5 times 100 over 1. Or you can simply find the percentage purity and minus it from 100, you now have percentage impurity. For instance, if you go to the calculator, we have that this is 88 point what? This is 88.6. The percentage purity is then percentage impurity is simply you minus this number from 100. It will give us 11.3. Forget this minus. I just don't want to waste time. Supposed to say 100 minus 88.69, not 88% minus n. So it's 11.3%, the mass of impurity, if they do ask you. Okay. Now, let's look at the salt analysis. I'll come back to other questions, other likely questions, but I want you to look at this salt analysis. I'll take you through this question. Look at this one, whereby the impurity is now on the base. The percentage impurity is on the base. They will not stay away from any of this. They gave us the pure acid, now made B impure. This one, if you learned the first one, solving this one is a bonus, I'm very sure. But before we come back to this second likely question, we will take a look at exactly the you see the follow-up question. Remember, the spaces are provided. Be careful, manage your, if you pour water on your question paper, nobody is giving it back. Remember, chemistry teachers should stay tuned. I'll teach you how to fill your practical reports, which is what you have here. This is the teacher's report. I'm using that of 2025 to teach you how to fill your report form, because if you don't fill your report form very well, you will fail your students. You will automatically fail them, and no good teacher wants to fail the students. Please, this live stream is meant to guide you well so that you learn some basic things. So look at this sort analysis. They said credit. Most students often overlook this statement. Even your teachers don't advise you to read them. Read these things so that you know what you are doing, okay? We said credit will be given for strict adherence to the instruction for observation, okay? The report form is for 2025, okay? 2025 did not have this salt, okay? Think 2025 was copper sulfate and glucose. We are analyzing lead 2 carbonate and starch. So look at the question where I'm talking about. Most times we don't care reading this question. They say credit will be given for strict adherence to the instructions for the observation precisely recorded and for accurate inferences. All tests, observation, and inferences must be clearly entered in this booklet in ink at the same time they are made. So it is tentative recording. You are not allowed to wait. Maybe we are saying use ink, don't use pencil. Don't use pencil. Don't write any part of this exam with pencil. In your question paper, make sure you are using pen throughout. If you are not sure, please, the relative density that question had is just for the dilute acid, not for the conc acid, okay? So let's continue. Please don't write any part of this in pencil. Don't use pencil, use ink. They say C is a mixture of an organic and inorganic compound. Carry out the following exercises or see. Record observations and inference from each test. Identify any gas or gases evolved. They now say put about half a spatula of C in a boiling tube and heat strongly, allow to cool. B says to the remaining portion of C, add about 2 cm³ of dilute triazonitrate 5 acid. Then that's HNO3. Stir well to dissolve and filter. Keep both the filtrate and the residue. For the Gambians, you watch my live stream some days back, you will get guided automatically. So Gambians, your salt analysis has been cleared well. Just ask for the link on this video, I'll give it to you. So to the remaining portion of stir well to dissolve. Now to the residue, add few drops of iodine solution. Then C says divide the filtrate obtained in BI into, as in the B above, into 3 equal parts. Then to the I, they say to the first portion add sodium hydroxide in drops until in excess. To the second portion add aqueous ammonia in drops until in excess. Then to the third portion, they say add dilute HCl, heat, and allow to cool. What do? You make your table. Make your table. When I finish making this table, we will just go and now watch the what experiment itself, so that you learn, and we now come back and record exactly what you observed. Okay, so thank you for tuning in. So make your table. NECO will make table for you, but WAEC will allow you to make your table. It's part of what scores you. Okay, you have your tests, inference, and test, observation, and inference. You don't need to give accounts. Like I came into the lab and answered the teacher talking. Is not needed. Okay, let me shift this a bit. It's funny now. You know, if you don't tell students, they will talk that story and say our lab was well arranged. For the chemistry teachers, I will also show you how to set your lab for standard exam. Okay, so chemistry teachers, please hang around. Students, we are settling you. Listen and ask your questions. All right. So here is our test, observation, and inference. All right. Test, observation, and inference is the way you record it. So we will take straight now, we move straight to the lab and see this experiment as instructed here. So when I finish doing the experiment, we now come back and fill the form on what we understand as the your questions. Okay, so ask your questions when you are seeing me demonstrate it. In case if they have not done the sort analysis for you, I'm going to move into the lab now and show you this experiment. Okay, but remember that we are coming back to fill this table. So far, this is the question we have handled so far. And remember, please, before that lab, we'll show you also the things we got for you. All right. Different grades. Today, this one is the stainless one. How many knives? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 1, 2, 3, 4, 4. Here is the test rack of different grades. Today, this one is the stainless one. How many knives? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 1, 2, 3, 4, 4. I'll break it down. I'm showing you we sell special laboratory equipment. I don't know if you have seen this type of test tube rack. In case you are running into this video accidentally, this rack is stainless. You can hold faulty test. I also have experts that do physics practicals. Okay, I'm showing you this the setup we use for filtration in the laboratory. Buchner flask to facilitate your filtration. Then here you connect the side arm where you connect your suction, and then to this suction. So this is our vacuum pump, which is also available for you if you want to buy industrial vacuum pump to create vacuum for your experiment. These are our new arrival. We are moving into the laboratory for you to see the real experiment. So please stay tuned. Which will do the filtration. It's a kind of creating a vacuum to increase the movement of liquid during filtration. And this is the filtration apparatus. Actually, the thickener flask is here, complete thickener flask. Here you close this, where you pour what you want to filter. Now we are showing you the types of burettes we can have. You see this one we tap, very soft. You just touch it and the liquid flows. You see it. There is no chance for breakage. The liquid is moving well. So please, when you say you don't want to waste your time, are you paying for this live stream? Please, you can go if you don't want to waste your time. We are showing you what we have for the experiment. For those that want to equip their laboratory, please, okay? Nobody's holding you there. Thank you for tuning in anyway. So if these things are annoying, this is our pipette. This is a graduated pipette and pipette pump. You might see me use them. You people tuned it. Historical radio. Yeah. Here is our separating funnel. Different size measuring cylinder. So place order for your laboratory equipment and reagents. You see this type of burettes. For those that love my practice, they are already quarreling. You have to buy these things, equip the laboratory. This one is with tap. It's available. You contact Easy World Science and Surgical Supplies to get all these things. So, okay, all right. We now have to do. I've added my indicator. This is the color. Don't add excess. I'll take a look at my initial. I said earlier that was 12.3, probably 12.2. It's in between 12.3, 12.2, confusing anyway. But take lower. So I want to take another shot. Okay, all right, I want to go ahead and do the titration. Before the titration, look at my initial. The noise is coupled with mistakes. It becomes annoying to me. Here is 33. We still have up to 20, so I will continue. So, the thing I lost a lot of, so that the initial here is 32.6. That's my initial. 32.6. That's all right. Yes. Please, after the titration, we are moving to the salt analysis, okay? To the salt analysis. So I gently... Just one titration to show you how we do the titration anyway. But there are some mistakes. Those that are live interact with the live and we are exchanging words. We are talking about your tomorrow being nice, please. Steven, they are telling you who cares about your name. Please, Steven, you're welcome. I care about your name. Thank you, guys. It's fun anyway, but let's not miss the targets. Let's learn so that tomorrow will be very nice for us. Add as well. Drop by drop, because I'm approaching and I'm there. So this is now 44.123. 44.3. So my volume of acid used would be 44.3 minus 32.6. 6, have you? So what's the difference here? Huh? $11.70. Okay, that's a bit too far from it, but anything 11.8, I wouldn't check the accuracy of this because a little thing. For the last one I did, I got 12 points, but this has been here for some time, so maybe probably a little contamination has happened. But any range from 11.8 to 12.5 is allowed depending on your own. Remember, this is just my rough. If I run it again, I'll get something close to that 12.1, which is what I got for the first time. If you watched it, I'll show you where I did that experiment. Now, this is it for titration. So anything about titration is over. Remember that these things are available for sale. It's the pipette pump. This one is the pipette bulb, very soft. This is graduated pipette. It can do the whole job. Just fix it here gently to hold you well. Wind this into pipette. I think I use it to prepare something that is colored so that you see. Simply wind up and it draws the liquid in. Simple. So then if you want it to release, just take it. You know, nothing is dropping. You now wind down. It will, or you just cut the knob. So for this one, you inflate and deflate and pipette any volume. We go to salt analysis, which is the main interest. So C is a mixture of lead-2-triisocarbonate 4 and then starch. That is mixture of organic and inorganic compound. They are not salts because starch is not a salt, but salt is organic compound. This might be. I take it out there. Then for teachers that are asking, the instruction paper say give each of your students 150. They say solution A will contain 150 cm³ for each student, made up of a solution that is composed of 5.60 cm³ of concentrated H2SO4, relative density 1.84, and percentage concentration 98%. That is the specification, a dm³. It doesn't mean you prepare 1 dm³ for one student. No. As I've prepared this one now, this is 1,000 ml. I filled it to a certain level and now added the acid, add it up to 1,000. What I will do is I will bring a conical flask. Like each student, I will now pour 150 for one student. Keep. This one keep. So it's just like serving your guest from your dish. That dish is what I told you to go and prepare. That in your dish, you should contain 5.6 cm³ of concentrated H2SO4 in 1,000. So when you add it, you mix well, and from that, you now add 150 for each student. Not that you prepare 1 dm³ for each student. That should be wasteful. Thank you. So let's do the salt analysis. This is my sample C, which is made up of lead-2-triisocarbonate 4 and then starch. The first thing that we might be asked to do is to put small parts and heat. If you do that, you will notice that gas will evolve, which will be colorless, odorless gas, and the gas evolved will turn lime water milky. If you are told to remember these things are... If you are live, remember, if you ask your questions, I will answer you, okay? So please, let's learn. I like that statement. Let's just use it to learn, okay? Ask your questions. I'm seeing your live chat. If you want me to explain anything, can I explain what again for you? Okay, maybe you are asking another person. Guide questions, guide practice, endeavor to follow the real instruction in the question paper in the exam you're writing. So let this help you instead of confusing you. This is mixture of starch, powder, and lead-2-triisocarbonate 4. So how do you do this? They say equal mass for teachers. It means if you measure 3 grams, is the light on? So this means that if you measure 3 grams of lead-2-triisocarbonate 4, you can measure 3 grams of starch also and mix them equal. All right? That's the equal mass of both lead 2 carbonates and starch. That's what they mean. If you mix 10 gram, measure 10 gram of starch, measure 10 gram of lead 2 carbonates, mix them together. That is your sample C. So I'm collecting small sample of C, put in a dry test tube or boiling tube and heat. This is, remember, likely things before we now go to dissolving in acid, then followed by filter. So here is my Bunsen burner. Okay, so on a gentle heating, it will turn slightly yellowish because of formation of lead 2 oxide, decomposition of the lead carbonate. And then if you continue, I don't know if it will be visible to the camera, it's showing that slight yellow, but when you continue heating, it will turn black due to charring of the starch. The carbohydrates, when you heat it strongly, it will undergo charring. Okay. I've not observed anything yet. Maybe I didn't mix well, but let me heat. Okay, I'll bring it closer to the camera very soon for you to see well. You see, gas is coming out, and that's the colorless, odorless gas. You see, cloudy something is colorless. And over here, I don't know if it's visible. Is it really showing that black? It's showing black, right? So that's the black residue. Remember not to say black precipitate, but it turned slightly yellow before turning black. I explained that yellow is due to the formation of lead 2 oxide from the decomposition of lead 2 carbonate 4, and the black is because the starch formed charcoal on heating. That's charring has occurred. In your inference, I wouldn't know what you should write here, but since it's slightly yellow on heating, you write lead 2 oxide likely. Then presence of carbohydrates or presence of carbon, because it's turning black on strong heating. But remember that there is colorless. We have calculated percentage purity. You joined late. Then after you go back and revise. For those that are live, thanks for tuning in. Please share and like. Give this live stream thumbs up. Please keep liking and sharing to get this video to reach the right audience. Spread the light, okay? Thank you for tuning in. Just keep liking, keep sharing. I'm very lucky to have someone like you, and you're also lucky to have a revision class for both teachers and students. Please like, please like. Thank you, thank you, thank you. Like and share. Odorless gas, which is that CO2, but you don't tell them CO2 colorless odorless gas evolve, which turn line. Okay, at this point, the colorless, odorless gas evolved, which turns lime water milky, and you can simply tell them in your observation, you now say CO2 gas from CO32 minus. When we go back to the worksheet, we will fill it well. Remember, we are here in the lab. After the laboratory, we go and continue filling the table. Okay, thank you guys for liking. Keep liking this. Remember, this class is to help you, inform you, to give you. I don't participate in my practice. These questions are just constructed to attract you to watch and learn. So read the questions very well in the question paper. This is Her Majesty's World Science Channel. I don't do my practice. I'm a scientist. So whatever you are seeing there is just to lure you, to attract you to watch. I'm sure if you listen well to my explanation, you will smile tomorrow. Please, don't be a candidate of malpractice. I am explaining this such that you can write the exam by yourself. For those that couldn't buy the equipment or that their school couldn't show them, I am showing you now the experiment, the way to conduct it. Thank you guys. Keep liking and sharing. Nice having people like you. So in any way, these questions you are seeing are just designed to attract you to be patient to learn. In other words, when you go to the examination hall, read the questions very, very well. Okay? The questions will not be far from what you're seeing, but they cannot be exactly the same. So even if I see the exact questions, I'm not bringing them online. Rather, I'll teach you. My students, my followers are always happy. Okay? Thank you guys. Thank you guys. So we now switch again to the next experiment. The experiment continues, please. We'll be right back. We'll be right back. No problem. So we're going to continue to add the, first of all, you'll be told to dissolve in HNO3 or any acid. So over here, you see, I hope it's visible enough there. So this is the HNO3. Notice the effervescence. When I add it, there will be, you see, that's evolution of gas. So effervescence occurred, colorless, odorless gas evolved, which turns lime water milky. Then you write CO2 gas from CO3 2 minus. And then you also write, because you'll be told to filter, you keep both the residue and the filtrate, all right? So here is my filter funnel. What you can do is, to avoid wasting time, you just filter and proceed with the little filtrate that comes out. Remember to rinse anything before using, and make sure that the water you're having is distilled water to avoid contaminating your analysis. So this is my filter funnel. Okay, I have funnel here, so if I left it, you rinse again. Then here is my filter paper. Maybe you don't know how to fold, you just, this circle, you fold along the diameter and fold again along the radius. You have 4 lips, then collect any 3 together and leave one alone. You have formed a funnel shape which will suit into this filter funnel. Thank you. You shape well. Thank you. See, for the compliments. That is said that is dissolving, shows it's partly dissolving. So there will still be, they say at about 10 cm or 5 cm. So, but probably it's going to be about 5 cm, so that we don't have it. Those joining the live stream are asking to calculate percentage purity. We have done that. We still go back and show you, but you go back to this live stream after now, you watch it and understand it, okay? We have taught that clearly well. Percentage purity is the mass of pure all over mass of impure times 100 over 1, which is the mass of pure is the mass that participated in your titration. That is the gram per dm cube of whatever of A or B in the titration, all right? Okay, you're welcome. Omoro, maybe if I didn't call your name well, forgive me. Let's go on with the experiment. We are going back to the laboratory. Stay tuned. Please subscribe, like, and share this video. You can also like my page on Facebook, Majestic Tutorials. Follow also on TikTok. I've not really established well there, so we will not only laugh and learn TikTok. You use Majestic Tutorials or Some Majesty Easy World at Facebook. Like and follow there. I'll be pasting more of this paperwork there, like the typed parts. I'll post it on Facebook, like the one that will have the test observation really typed. Here I'll be writing it with hand, and subsequent ones, if I have more followers there, this live stream can also take place there. Majestic Tutorials 1 is what you search on Facebook and on TikTok to follow. Majestic Tutorial, MAJESTIC, Majestic Tutorials 1. Or I'll drop the link of the channel down in this live stream. You click and follow. Thank you, guys. Let's go back to the laboratory and continue our experiment.
The effervescent has stopped, so I've already added excess. So I shake well, pour here. In my next analysis, I will use vacuum filtration to facilitate. But what you have to do is you keep this. Any little one that drops, we can collect and analyze. All right? Then another possible thing is that you might be told to just collect a small sample of mixture D without dissolving in anything, place on a white tile, and drop iodine. So here, I hope it's visible. Is it more closer now? So this is the sample C mixture. You drop iodine to it direct. Dropping iodine is actually test for starch. So no matter what, anytime you are told to drop iodine in this experiment, you simply report blue, black coloration.
All right, we are testing for starch now, and we use iodine to test for starch. Starch turns blue-black in the presence of iodine, okay? So in this experiment, if you are told to add starch, just know that your observation is blue-black coloration. Your inference will be starch present. I'm about to turn.
So here, I'm dropping it, and it's obviously blue-black there. Coloration, your observation is blue-black coloration. Your inference is starch present, so turn blue-black on adding that. So as we use this to wait for our little filtrate to collect, the total is taking a lot of time before it will start. So in this case, I will analyze further again, theoretically, as we wait for the filtrate to form gradually. To solve this problem of filtration, you can order for your filtration apparatus together with the vacuum pump, which I will also show to you and is available for sale. I forgot my Buchner funnel. That's what I could have used for this filtration to make it very fast and accurate. That is in case if you're involved in production of these chemicals, I use them for the industrial production, okay? Now, forging ahead, what are we expecting? After the filtration, we will have a colorless filtrate and a white residue. Now, to the residue, you'll be required to add still iodine, like I did. The idea is that the carbonate dissolves, the lead-2-triazole-carbonate 4 dissolved in HNO3 to give us lead-2-triazole-nitrate 5. So the filtrate is expected to be the lead-2-triazole nitrate 5. And there will be presence of lead-2 ion. So anything you are now testing with that filtrate, you are testing for lead-2 ion. Theoretically, when you test for lead-2 ion, you use aqueous ammonia, aqueous sodium hydroxide, and aqueous ammonia together with dilute HCl, followed by heating. So these three reagents are needed for the analysis. Don't know if my filtration is even happening at all. The filter paper is the porosity is high. The porosity is small, I mean. So let's go on. This sodium hydroxide, aqueous ammonia, and HCl, three of these reagents will confirm lead-2 ion. If you add sodium hydroxide in drops, it will give a white precipitate, which is not gelatinous. And the white precipitate will dissolve in excess of the sodium hydroxide. Why? Because
silver nitrates, I don't think we're going to go use it. We're not going to use it probably for silver nitrates. This analysis, we might not use it. Remember that all the reagents that we are instructed by WAEC, that we have, that teachers have to provide, all of them must not be used, okay? And probably you're supposed to have them in your laboratory, but just be patient as I guide you, put through all this. Please like and share this video if you are profiting from it. Remember, we'll still go back to our likely questions to solve again. Many of them, then please, like I requested, You can look at the link for the Majestic tutorials on Facebook and on TikTok. You can follow me there so that I'll keep doing this work over there also. All right, so let's continue with this. I think I've answered you. Every time you have questions, please send your questions. I am here listening. But when you are enjoying yourself, exchanging vibes, no problem. Thank you for tuning in. But let's not forget the major thing. Learn something from this live stream. Please, it is free.
Ion, together with zinc 2 ion and aluminum ion, are all amphoteric, meaning their hydroxides behaves like acid in the presence of a base like sodium hydroxide. So the sodium hydroxide, when you add it now in excess, will dissolve the resulting lead-2 hydroxide, forming a clear solution. All right? Then, with aqueous ammonia, lead-2 ion will form white precipitate, still not gelatinous, but will not dissolve in excess of the aqueous ammonia. Reason is because
Latif, you're welcome.
the reason is because lead-2 ions are not transition, and they are not transition cations, and they cannot form complex with ligands such as ammonia. I know what I'll do to this delayed filtration. The upper part has settled, so I will use my dropper to collect the clear upper part of this. If filtration is delayed like this,
that's what is going on. Let 2000 Cameroon starch analysis. That's what's going on. You listen before you send in your question, please. Teach you, and that's what is happening here. God will bless you too, my dear Favor.
Filtration is taking longer time. His filter paper is very speedy. It's not all that too porous for ultra filtration. So what I want to do now is I will use this dropper to pick carefully. The light is reflecting. Yeah. I've picked because it has settled. So when filtration is delayed, this is clear. I will now add my soda hydroxide. I hope you see view the camera and look at what I'm doing. Is it clear? So I will add in drops. If you add and there is no visible reaction, it's showing that there is excess acid here consuming the sodium hydroxide. So don't be worried. As you can see here.
We say fear his mouth.
Okay, you keep adding until you see it now. It gives us white precipitate, which is not gelatinous. Okay? So it is white precipitate, it's chalky, it's powdery, and not sticky. Leave that. Just tap where you want it to focus. Thank you. Don't need to keep tapping it. So this is what we do if filtration is delayed so that you don't waste time. As this the upper layer, add in drops, there will be white precipitates, not gelatinous. Then you add in excess. Let's see what happens. Precipitate dissolves in excess. So don't worry, leave it. Precipitate will dissolve in excess to form a clear solution. That is lead-2 ion, likely exactly what I explained to you. So I'll keep it and pick my second portion of the filtrate, the same way I did, and test with aqueous ammonia. Be careful not to pick the residue which is at the bottom. Just press and place here.
So what I'm actually doing now is, because the filtration is delayed, you don't know, waste your time in the hall saying let me wait for it to filter. Immediately it settles, the residue will settle at the bottom. It will be very slow. Remember, we use vacuum filtration to facilitate filtration process normally in the lab. So what I'm going to do is just use your dropper and pick the upper clear layer. That's what I'm doing now. So remember, if you're live, you ask your questions, you like this live stream, share it on your WhatsApp status with your group, those people that will enjoy it on your Facebook. Please share it so that people will benefit from it. And do you know the good thing? After exams tomorrow, I'll still come back here live to do the corrections, so that we also discuss. If there is any weakness, we review the question from WAEC. We have to see them and learn from our mistakes, or rather celebrate. Definitely, I want you to celebrate because you joined this live stream. All right. So I am picking a small sample. Since filtration is delayed, I have to pick from the surface and place in my test tube and continue my analysis. So let's go back to the laboratory.
Is okay. So this is a sample of the filtrates. I remove my soda dioxide, time to add aqueous ammonia. Normally you can use this dropper to do it, okay? Or if you are careful, you can still use free hand to add the aqueous ammonia. If you add for the first time, there is no visible reaction. It shows that there is excess acid which is using up the ammonia. So you keep adding to neutralize off the excess HNO3. So here we have still white precipitate. It's never gelatinous. Lead doesn't form a gelatinous what? Precipitate. Rather, it forms powdery, but sometimes, I don't know why standard they say they may not be accepting powdery or chalky again. But if you say white precipitate, no problem. But when it's sticky, you say gelatinous. But today's analysis, it is not sticky. It is powdery, free flowing. Although you might notice something gummy, that's interference with the starch. So that's why you don't just mix any sample and say you analyze. If I'm looking at this thing, actually, I can still see small sticky thing because of that starch interference. But please look beyond that. It's not everything. They shouldn't have mixed it. They're supposed to keep it aside. A, sample C and D. You analyze them separate because of interference. Now, in excess, I'm adding ammonia in excess. See, this is excess. Remember, this is the one I got with sodium hydroxide. So it dissolved in soda dioxide, but this is ammonia. So in ammonia, it persists in excess aqueous ammonia. And when it persists, your
Okay,
inference, you
thank
see
you for having
lead-2
confidence.
ion
Ayomide.
present or lead-2 ion likely, okay? Then the last work here, the third portion, you use dilute HCl, heat and allow to cool. This is what we confirm lead-2 ion for us. But remember, potassium ions, iodide ions will form yellow precipitate with lead-2, but iodide ion is not provided. It's a nice experiment whereby if you mix potassium iodide with any compound containing lead-2, it will give you. So I'm adding the third portion. Our filtration is happening, but very slowly, okay? So don't waste time saying I'm waiting for the filtration to complete, okay? This is my HCl. Normally, it should be in brown reagent bottle, including the HNO3, your silver nitrate, because they are photosensitive. These chemicals that react to light. I'm adding HCl. This time around, not in drops, not in excess, just add it. They want to precipitate what? Insoluble lead-2. Okay, formed and eventually disappeared. We calm down, it will still form back again. You see, the white precipitate is formed. Then you are required to heat. You can see the white precipitate is still not chalky, it is still not gelatinous, it's still powdery, can be free flowing. See, it's just hanging, settling at the bottom. So I will heat and allowed to cool. On heating, is expected to do what? Dissolve. So what you will do to get your results so quick, remember we heat with boiling tube. I didn't get anyone out here. But these test tubes are borosilicate. Even this is a borosilicate glass, and they're also pyrex, but it's not meant for heating. You can use it to prepare something hot. I'm adding water so that there will be enough water to dissolve it when I heat. Okay? So the next thing is to heat and allow to cool. On heating, the precipitate, I say, is expected to dissolve. Why? Lead 2 chloride is soluble in hot water, but insoluble in cold water. Remember, you're on with Sir Majesty's World as his majestic tutorials. So subscribe and share this video if it is benefiting you in any way. Okay. So I'm going to heat. Remember, the precipitate settled, not that it dissolved, though. So don't confuse the precipitate settling with dissolving, you see? So I have to shake it back. Now, heat so that we obtain a very clear solution. It's already warm, so it doesn't even require much heating. It's very clear. There is no evidence of precipitate again. So this thing is hot, but let me try shaking. Wow, don't try this. So, but there is no more precipitate. So precipitate dissolves on heating. If I keep this, it will reappear on cooling. And you now write on your inference, lead 2 ion confirmed. So because it's only lead that will be able to give us white precipitate in drops of soda dioxide that will dissolve in excess of soda dioxide. Lead 2 ion will give us also white precipitate, which is non-gelatinous with aqueous ammonia, which we persist is insoluble. Reason: lead 2 ion is not a complex, is not a transition ion, and it doesn't form complex ion with ligands such as ammonia. But copper dissolves, zinc dissolves, because copper and zinc, they dissolve in excess aqueous ammonia because copper and zinc have the ability to form complex ions in the presence of ligand. Then lead 2 ion forms also white precipitate, which dissolves white precipitate with HCl, which dissolves on heating and reappear on cooling. Then they might replace the HCl with barium chloride. If I
All right, this is it. We proceed to the last part of the experiment. But remember to bring in your questions. Before then, let's display again the questions that we are expecting. Please, the questions you will see here are likely questions which will guide you very, very well. Okay, we are done with the analysis. The next video, I will show you another possible scenario. Remember that when you are told to add acid, tomorrow they may tell you to add H2SO4, they may ask you to add HNO3, you might be asked to add HCl to the solid sample. If you ever add acid to sample C, that is the mixture, there will be effervescent. Colorless, odorless gas will evolve. And if such happens, your inference will be CO2 gas from CO32 minus. All right. So let me go back to the solving and the questions, likely questions. We will come back to the laboratory. Okay. Over here, we have the questions we are done with. Remember, I think for the teacher's report is necessary also. We'll come back and teach the teachers on how to do with their report form. Okay. To do the reporting, that's which matters a lot. If you don't report properly, you will fail your students. Okay. you have to be careful. But in a situation whereby the teacher's report is missing, WAEC will find the most repeated endpoint and use for everyone. Okay, this is the second likely question where we have solved for titration. It is similar method for the first question we have solved, which I will show you here. This one now is talking about the impure sample of sodium hydroxide. You still follow the same pattern, the same table. Remember that a teacher should not go inside the examination hall to alter endpoints. No, if you have prepared your A and B and keep for your students, there is nothing that will make you go inside the hall and change your endpoint in order to rhyme with the question paper. And again, use the concentration you see in the question paper tomorrow. You are seeing 0.103 mole per dm cube. Tomorrow, if they say 0.05, use it. Don't be deceived by what you are taught. This is for preparation. Don't swallow this thing hook, line, and sinker. No. For you to see more of this preparation class, you can all right. I am trying to bring up the other likely questions on titration, please, so we can now carefully watch them. You try to solve them. Think we are live. Make sure you screenshot them and do your please. Zinc and aluminium should not be included here because the precipitate will not be gelatinous, and zinc and aluminium forms gelatinous precipitate, but lead here forms powdery or chalky, so we should remove zinc. Even though zinc and aluminium are soluble in excess hydroxide, fine, but how about the nature of their precipitate? You simply say lead 2 ion likely. Including aluminum and zinc there is non-scientific. So let's focus, please. This is likely question 1 for preparation. You screenshot. I hope it's clear on the screen. Okay, is clear now for my side. All right, let me try zooming in. Yeah, okay, sorry about that. Then I scroll. This is likely question 2. You know they clear? So sure. I believe it is. That's why I do wait a bit. Okay. Continued. I'm sure if because of the waiting it will be clear before I can leave. We go to likely question 3, which is actually the one that we are going to solve right now for titration. I made it. If you are good with all these likely questions together with the one I have solved already, then this one is all about where they will hide the base, call it X. Instead of calling soda dioxide, becomes, they will call it XOH. Remember that you don't know, whenever they hide this thing, warning, if you are doing your calculation tomorrow and you find out that maybe the question said that the X is unknown and you are getting the value of X to be 28 or 30, don't be worried, because you already know that sodium is supposed to be 23. If it is not 23, that doesn't mean you're wrong. No, you are not wrong. What they mark is your calculation step, not actually how accurate this. It depends on the endpoint you are using and how they change the concentration. So don't struggle to claim you know it. Who told you that X is supposed to be 23? Let's assume they decided to hide the sodium hydroxide, the sodium there. So this question is where the base was hidden. The next likely question is where the acid was hidden, H2Y instead of H2SO4. Don't claim to know that it is H2SO4. Don't give over reporting. So I'm displaying these questions so that you can go through them. Then you visit Majestic tutorials on Facebook, where I will post these calculations to the worksheet for all these things. All right, just subscribe and follow there, and also on TikTok. Then this is it, or in the comment section there, if we still have time. This is arranged. This likely question 5 is a bit advanced, just in case, but I'll read it out. They say A is 0.103 mole per dm cube diprotic acid. The word diprotic is just like saying dibasic. Diprotic acid H2Y. Then 200 cm cube of solution A contains 2.02 gram of A. B is a solution of monobasic base, is correct, containing 4.20 gram of the base per dm cube. If they say 4.20 and say they told teacher to measure 4 and they are saying 4.20, who told you that they are measuring 4? You don't know anything except to follow the questions the way they appear. Of the base per dm cube of solution, which represents molarity of 0.105, that's mole per dm cube. They now said, you just joined, we have done salt analysis, we even went to the lab to do the salt analysis. The normal English, they say put A in burette, all this and this. What matters is we look at our tabulator of burette. The same table I used in the previous question is what we use, where here is, from your results and information provided, calculate the mole ratio of A to B. This type of question, they will not give you equation or the reaction. You are calculating the mole ratio. Please, if you are told to calculate the mole ratio, this is where students will be a bit off balance. Let me clear the air for you. If they say mole ratio, simply know that CAVA over CBVB equals NA over NB. Simple. CA times VA is equal to NA. Then CB times VB is equal to NB. Let's assume that's this question. They say from your result and information provided, calculate the mole ratio of A to B. That's the mole ratio of the acid to base. Therefore, there is no equation. You don't know this. So you now put your values. Let's assume using the values here, 0.103 times 12.10 divided by 20, divided by 0.1, which is the base, is CB, then times 25. If you press this, you have to get half. Okay, 0.103 times 12.10 is what? Let me use the calculator anyway. 0.103 times 12.10, 0.103 times 12.1 is 1.24. 1.24 divided by 2.5, because 0.1 times 25 is 2.5. All right, divide by 2.5, which will give you 0.49, approximately 0.5. 0.5 means half. So that's 0.49 whatever, which is 0.5. And 0.5 means 1 over 2. So the mole ratio of acid to 1 over 2. Simple. So if you encounter this type of question, don't panic, all right? So they will not give you equation, but this likely question 5 will be highly unlikely, but I'm making sure that you don't become frustrated tomorrow in any way. So I'm going through once again. This likely question 4. You're welcome. Thank you for your compliment. Thank you guys for tuning in. Please like, subscribe, and share this. Send in your questions. I can see them. Immediately you send them, I will read them and respond to them. Please, remember, these are likely questions, not the exact thing you. Okay. Give this video a thumbs up and share it. And also, if you like what we are doing, you can also support the ministry. Of course, if you can, if you have gained anything from this live stream, my OPay should still be my same number, 0765166217, just for support. Any amount can go a long way, but we are doing this mainly for sacrifice and trying to tell you that I'm a scientist also and I sell laboratory equipment and reagents. But in case if you want to sponsor our next live stream or say thank you for what you have done, this is my OPay account, of course. So that's my number. Copy the number correctly, and we will appreciate you greatly for your support in anticipation. Now, for salt analysis, I will also give you many of the likely questions for salt analysis. Okay, but at the end, it is still saying the same thing. It will be exactly the same thing. The pen is off. Can now go back. So we are exiting pencil now. Here is the salt analysis question, which is similar to the one you have seen. So let's just go back to this and continue with the teacher's report. Time for the teacher's report, please. I used 2025 reports to bring a sample here. This is the cover for teachers, okay? Who said that WAEC is not giving calculator? Why giving fake news? Although I don't know about that. So look up, you'll be provided. This is for 2025 anyway. You write the center number, use block letters, the date. Maybe I'll just use this and fill automatically so that you understand what I'm saying. I will use blue pen. So remember, you have to write this after the exam. You as a teacher, this is mainly for teachers now. The center number, maybe you start with 4152048. I've forgotten the number, but you write this way. Date, we'll take tomorrow as the date, which will be tomorrow. Probably is what, please? I'm no more update. Tomorrow's date should be, I think, 20th. Okay, you just write 20th May, 20th May in block letters. Okay, for teachers, remember this is what they will use to judge your students. 20th May 2026. The name of school here, the name of school here is Easy World Science School. Easy World Science School. The name of teacher providing it in block letters. Sir Majesty, you write your name. I'm writing mine, that's your name. Sir Majesty, Sylvester, or Easy World, whichever. Then you are done with this page. Okay, you now go to the next page. If I say done, I'll still come back. We go, the next page is here. Now remember, this is not for this year. I use that this one have not come out, is in the hall that they will bring it alongside. And you as a teacher always remind the invigilator of this report. Even if he's forgetting, you tell the invigilator, what about the report, please, you need to fill it. You now go to the instruction they gave you, the instruction paper they gave you. Copy exactly what they say A is. Like this year, A is 3.6, not 3.6, sorry, is for, I'm using that of the Gambians. Please, their own is 3.6, but for Nigerians, their A is 5.60 cm cube of concentrated H2SO4. What you see tomorrow is H2SO4. Then B contains, for this year, 4.0. So you simply write 5.6, assuming tomorrow. You write it here, not here. I just wrote it so that 5.60. Here you write 5.0. Then here you write you as a teacher, you're expected to do the titration in the morning before giving it out to your students. Okay, I've shown the salt analysis. This funny thing, when you join, you ask. We will still go back. State the volume of A required to neutralize. As a teacher, you delete as appropriate. Delete means if your school use 25.00, you cancel this. Just cancel it. Then for this experiment, maybe your own endpoint, your first titration, you got there is no rough here as a teacher. You have to do your rough and now record here. There are 3 questions you are going to answer in this practical for the person asking. You will answer question 1, which is titration, having the highest mark. Then if you need to know the guide, anything you want to know about this, you just ask me. I'll send the link to the video. I have guide on chemistry, biology, physics rules, WAEC rules on how to score well. So, but for teachers, let's continue. Let's assume here your first is 11.90, and the second title you also got 11.90 is possible. In your third title, you get now 12.00. You now add this and divide by 3 to write down here. They have already added your CM cube, okay? If we go to the calculator, 11 point, we can simply add this and remove 0.2. That's 36 minus 0.2 is 35.8. So this is 35.8 divided by 3. So 35.8 divided by 3 is 35.8 divided by 3 is 11.93. Okay, so you now write your endpoint as 11.93 cm cube. Then this page is over. You now go at the back where you will sign. You have to go at the back where this place is. If you have any difficulty in providing the specimen, or if there is any student that suffered any difficulty, which most times schools don't have, they wrote it down there. Details of any difficulty or difficulties experienced by any candidate should be reported below, stating the name, serial number, as well as the index number. Maybe the child suffered acid burn or breakage, or sometime physical wound or chemical wound, or the child is unable while doing titration, something happened that is not good. You mention it as part of the difficulty. It will help WAEC to mark such child and also help them in making next decision. But most times we don't have time for this. Nothing will happen, my dear. And even you teacher, then here I didn't snap it where it's not clear. This is the back of the report form. You now sign and the supervisor will sign. You make sure you sign. The supervisor will sign. And they bring this thing 2 copies, the one for your school and the one that you put back in that paper bag that they will pack the answers. All right. I think we have settled teachers for report form. We now go back for the salt analysis. For this salt analysis, we have done some part of it. Let me check if you remembered anything. When we heated this test tube, we heated it, it turned yellow and then black. That's, you write it there. I want to start my report from just to tell you how to do your report. The remaining C and R2 cm of dilute energy. So you just say C solid. Okay. C solid. Maybe because of time, I think the live stream is taking longer. It's expected to end in highest 2 hours, and I think we have exhausted that 2 hours. I want to show you the one I recorded yesterday. It will be very helpful. Okay, look at it. Halfway there will be C plus heat plus cool. There should be, that's after your filtration. You give us this, then plus HNO3 if effervescent occurred. Remember, they can use HCl instead of HNO3. Okay, instead of HNO3, they can use HCl. Tell you to heat and allow to cool, which I want to show you lastly, and we end this endpoint. I mean this live stream. Remember, you're on with Majestic Tutorials. Okay. detecting elements. Is that element or we detect an ions, not elements, detect gases. So this is the format you follow to fill. All right. Every other thing, the rules on how to report, I'll share the link. Let's just go back and watch the last part of the laboratory experiment for the salt analysis. All right.
So I want to So I want to take another shot, which is probably using HCl, dissolving in HCl instead of HNO3. With this, you can kill two birds with one stone. This is my sample. See, I will be required to add HCl. Remember, if you are told to take this with spatula and heat direct, it is still the same thing. It will give yellow, slight yellow residue, then black residue. Meaning, as it is, now take it like this way with your spatula to a non-luminous flame. What I'm doing now is instead of using HMT, I'm using HCl. I said the similarity is that there will still be what? Effervescent. Remember that after filtration with HMT, I said the similarity is that there will still be what? Effervescent. Remember that after filtration with HNO3, you'll be told to keep the residue, or you'll be told to add iodine to the residue. You still report to blue black, as you can see here. So I'm adding HCl. There is effervescent, obvious effervescent, but it will not. The more it's dissolving, the more it's forming a more insoluble what? Precipitate. So this time around, you'll be asked to go and heat. See, it's no more effervescent, so I've consumed the whole carbonate. This time, you'll be asked to heat it like this, direct. They ask you to heat like this, always add water so that you can increase the solubility. More solvent will give you quick answer. Now, what happened is that there won't be any need of telling you to filter and keep the residue, because even if they filter here, the filtrate will not contain enough lead-2 ions. It will not contain enough lead-2 ions. But let's try. How do I check? I will just pick small parts when this thing settles and test for lead-2 ion using sodium hydroxide. So there won't be lead-2 ion left, because the lead-2 ion will still be converted to another insoluble compound, which is lead-2 chloride. So I'll pick it. This is a sample, even though it has not settled because of some starch contamination. Okay. We are checking for the presence of lead-2 ion inside the filtrate. They will use sodium hydroxide and check if it gives us then. You see, I've added. Maybe I should add it. See, it's not showing any no lead-2 ion, because it will dissolve the lead carbonate and another insoluble compound, lead-2 chloride, will also be formed. So there is no lead-2 ion in the filtrate. So when they use HCl, there won't be any need to tell you to filter. But shockingly, they might tell you that because maybe the person that is asking the question has already concluded in his mind, this is what I think. But the experiment should not be assumed. Please, especially those responsible for asking this question, try to do this experiment before you bring in question. What you think is not always how it is when you go for analysis. You will discover a new thing. You will be surprised, because they might mistakenly say add HCl filter. Keep it now, divide the filtrate. If you divide the filtrate, you are not going to see any lead-2 ion, because the lead-2 ion will still be converted to insoluble lead-2 chloride. Okay, but when HNO3 is used, you will see lead-2 ion. What if H2SO4 is used? You will not also see lead-2 ion in the filtrate, because H2SO4 will react with lead-2 ion to form lead-2 tetraoxosulfate-6, which is also insoluble. Alright, so it's HNO3 that they can use and ask you to keep all the residue and filtrate. What if they ask you to add to water? If you add this sample to water, it will not dissolve in water. So you simply say C is insoluble in water, because both starch and the 2004 do not dissolve in water, but they dissolve in acid. Alright? So I'm giving you all the possibilities so that you'll be well prepared to do justice to this exam. Remember, say no to examination malpractice. Whatever you see while watching this video is just to lure you, to make you watch it. I'm sure you are learning something. It's not a crime if you write the exam and you say you must not copy. You are an image of God, you have something upstairs, and you have visited Sa Majesty's world. So you should be able to do something. Stop doing runs. Are you a product of runs? Were you plated by runs? I'm sure you're not. So, if you are watching this, I'm sure you have to know that you have more than you think in yourself. Go to the examination hall, do the right thing. This is science, it's very easy, it's open for everybody. So, say no to examination malpractice. It doesn't help our nation. If you kill our education, you have killed every system. You know, when you are educated, whether I know what to do, the wrong, the right. Okay? So thank you. Sorry for deceiving you with the clickbait, but somebody like you could have watched, if not that clickbait. So I think it suits you anyway. Now, the next thing is we are going to hit this and then allow this to do what? To cool. If you hit this, it will dissolve. Why? Because lead-2 chloride is soluble in hot water, but insoluble in cold water, just like we observed here. Or if I like, I can go and hit this direct without having to use test tube, but you are going to use test tube.
Okay, we are back. We are almost concluding this live stream, but before I conclude, I must say thank you for tuning in. This will help you very, very well. This live stream is for those that might find it difficult to do their revision. When you are watching, I'm sure I'm helping you, and it will be very much interesting for you than bringing your book. This thing might be boring in any way. So please, thank you for visiting. Much love. Stay majestic as we continue the experiments in the laboratory.
Dissolve it. Not that the water will dissolve it, no. Because even though it's soluble, it has also a level the water can take. And again, what happens to the starch? The starch will also dissolve because starch is soluble in hot water but insoluble in cold water. So we won't be surprised if you notice gel. If there is anything gelatinized in there, it is because of the presence of the starch. Okay? The cloudy thing is still there. To avoid this from cracking, I want to increase the volume of water so that my beaker will not crack. If you watch where the intensity of the cloudiness of the solution is decreasing, the solution is almost boiling. Alright, so yeah, we have now a clear solution. If you watch well, there is no more any precipitate remaining. So it will dissolve on heating because both starch and the 2000 carbonate 4 is soluble, both starch and the 2-chloride which was formed when I added HCl to the solid sample. Okay? So having watched all these possibilities, I'm very sure now that you can do your exams very, very well. That is only if they decide to use HCl. You are on this analysis easy work, so maybe you continue with other theoretical work because this live stream will do the theory, do the practical, and also do the calculations. Prepare you 100%. Watch it, is very clear. And allow it to cool, but the cooling will not be here. So you don't wait and tell the examiner, I couldn't wait before. It's obvious. Allowed to cool, it will reappear on cooling. Maybe after the exams, I'll still do correction with the question. Then, if you are the type that believe in my practice, please don't chat me for any runs because I'm not available. Rather, you can also chat me to teach you how to do analysis. Chat me for your laboratory equipment and reagents, trusted ones that are accurate in giving you results. Buy from a reliable scientist in case you want to develop your school laboratory and make your students real scientists. I am available. Contact me with +234 7065 166217. And majestic, affordable, and reliable. Enjoy your day. Come back for testimony.
So this is the short in case if they decide to use HCl to dissolve this lead carbonate, if not HNO3. What will happen? Effervescence will occur, less odorless gas will evolve. But the question is that as the HCl dissolves the carbonate, it will also form another insoluble compound, which is lead 2 chloride. If this happens, what should be your observation? If they tell you to add HCl and filter, I showed you that if you filter it, remember when they tell you to add HCl and filter, if you filter, the filtrate will not contain lead 2 ion. Why? Because the lead 2 ion will also react with the chloride to form lead 2 chloride, which is also insoluble. As you saw me in the beginning, I tested the filtrate for this one with sodium hydroxide. It did not show the presence of lead 2 ion. So lead 2 ion can only be present in the filtrate if you use HNO3 because it will form lead 2 trioxocarbonate. Lead 2 trioxonitrate 5. But when you use HCl, the thing that will form is not going to give you lead 2 ion. See what I'm saying here? So the thing I'm explaining here is simple. If you use HNO3, it's very simple. It will dissolve this carbonate to give lead 2 trioxonitrate 5 plus CO2 plus water. As usual, when acid reacts with carbonate, they will liberate CO2 gas and water. So we will be analyzing this one. This is lead 2 ion. It is soluble. This is aqueous, this is gas, and this is liquid. But this is solid, but this is aqueous. But when the acid is used in the second one, they may unlikely use HCl. But if they use HCl, the reaction that will be happening should be lead 2 triazocarbonate 4 will react to form lead 2 chloride. Funny enough, lead 2 chloride is still insoluble. Lead 2 triazocarbonate 4 is also insoluble. HCl is of course soluble, plus CO2 plus water. So this is solid. That is, it will still not have lead 2 ion. So if you add HCl to the sample C and filter, nothing will be in the filtrate. The filtrate will only be water. The CO2 will go, and the water do not have lead 2 ion because lead 2 chloride is insoluble. So it's only when you use HNO3 that it will give you possibility of what? Lead 2 ion. If you use H2SO4 also, there will not be, you cannot see lead 2 ions because it will still form insoluble lead 2 tetraoxosulfate 6, which is also insoluble, plus water plus CO2. So the ones that they will likely ask us is this one, likely. But the live stream is preparing you against all odds, whether they use this or this. Now, I want to teach you what to, I've taught you what to do with this one. They will tell you to divide the filtrate into two, which have the lead 2 ions. But if they use HCl, they will not tell you to test for lead 2 ion in the filtrate. There will be no need for filtering. They will ask you to heat it and allow to cool. Now, what do I mean? You will use one stone to kill two birds, like I said in the beginning. What will happen? Let's assume they use HCl. If they use HCl, this is your test, your observation. I'm being fast. I'm not writing it complete. Your test is simple. C plus what? Dilute HCl. Aqueous. You make sure you tell us aqueous. They will tell you to heat and allow to cool. plus heat plus cool. Then this test alone can confirm triazocarbonyl ion and at the same time confirm lead-2 ion because you have seen HCl. Your observation will be effervescence occurs, effervescence occurs, colorless, odorless gas, liberated, or you say evolved. Now say gas turned lime water milky or gas extinguished glowing splinter. If they tell you to put lightest splinter, you say gas extinguished lightest splinter. So evolved, say gas evolved which turned lime water milky, which turned lime water milky. Then you now continue your observation on heating. The only thing is that they might ask you this one separate and now tell you heat the resulting solution up separately. You can now continue your, see what I mean? The question might appear like this. Just be careful to follow up. They will tell you add C plus dilute HCl, first question. Then your inference here is what? CO2 gas from CO32 minus. That means CO32 minus is present. All right. Now, it is also possible they now tell you solution, you say mixture above, mixture from, if this is called I, tell you mixture from I above plus heat plus cool. You now report what? Dissolved white precipitate dissolved on heating and reappeared on cooling. You simply write our inference here will now be what? Lead-2 ion confirmed. Since we already know that we added dilute HCl here and it gave us effervescence, we confirm a carbonate because of the acid, but on heating the resulting mixture and it dissolved on cooling and reappear, it dissolved on heating and reappear on cooling, it confirms lead-2 because lead-2 chloride is soluble in hot water but insoluble in cold water. So when the water is cold, it is what? Insoluble. But when the water is hot, it is what? Soluble. So when they tell you to heat, they are just providing hot water. So this is, I'm not positioned this possible. I'm looking at the first shot, like where you use HNO3, okay, to divide by 2. If you have your questions, God bless you too, my dear. You come along with them. So we come back here and finally finish up. I'll go through the questions again. The questions I constructed for you to see them once again. So over here is just the clickbait to lure you to learn. I believe that you have learned something. You will not regret, of course, participating in this live stream. Here is the question I designed, constructed on salt analysis. You look at it well for those that did not join us in the beginning. Now, this is the titration question, likely question for titration. Okay. And then over here is the one we solved already. We have the questions here. Okay. We solved it with the table. This is the table given. The follow-up questions, this is for teachers' reports, which I have settled for teachers. I think this one now is the one that is following the other question that made B impure. Remember that you're allowed to rule your line here, solve here and solve here. But if you pour water on your question paper, nobody is returning. Nobody is giving you another one again. Okay, so far so good. I thank you guys for tuning in to this live stream. Remember, you are on with Her Majesty, your reliable man of science. Please, for your laboratory equipments and reagents, you contact me so that you will have the best quality ever that is possible. When quality speaks, then Her Majesty's word speaks. Okay, we want to display some of them. You think this is a sodium diammonium sulfate for Sierra Leone. I provide the salt also. Watch my live stream here, where I did live stream for every part of the Africa, Nigeria, Gambia, and Sierra Leone. You know, they have different salt samples. And here is our burette with tap. This one is burette with tap. Burette with tap. Special one. Very much available. That's your direct message. You get exactly what you're looking for. Very much flexible. You can lock it. And it's 50 mil. Here is your graduated pipette, 25 mil. Put it, very gentle, you control it. Put it, very gentle, you control it. Let's see the filtration apparatus. 1 liter, 1,000 mil. Okay. As soon as I come. Oh well. Use the connector. Then here you connect this is the side arm where you connect your suction, and then down to the suction pump, which will do the filtration. It's a kind of creating a vacuum to increase the movement of liquid during filtration. And this is the filtration apparatus. Actually, the beginner flask is here, complete beginner flask. Right back.
Majestic periodic table is here to rescue chemistry students everywhere struggling with the periodic table in classrooms, lecture halls, or laboratories. Worry no more. The Majestic periodic table has arrived to solve 90% of the confusion students face. This masterpiece behind me is not just a chart, it is also a summarized chemistry textbook packaged into one powerful table. Every element box contains at least 9 G facts, beautifully organized and easy to understand. And yes, it covers the electronic configuration of all 118 elements. The colorful design highlights important trends at a glance, making memorization almost fun. Yes, chemistry can be fun sometimes. It also teaches the basic rules and laws that govern how elements are arranged into groups and periods. So students no longer have to cram what they can simply see with their eyes. Now, here's the exciting part. You can customize your own copy with your name, your school or institution, a friend or loved one's name. Perfect for gifts. It comes in different sizes, different materials, and we deliver anywhere exactly how you want it. The most informative periodic table ever made is finally here. Get yours today and make chemistry bow for you.
All right, this periodic table is designed by me, is necessary for every chemistry laboratory. As you can see, she presented it very well. I designed it. It's very much informative. You cannot find a table that is more informative as this table. Let me show you the details of that table. You can order for one, please. For chemistry teachers, for institutions, let's bring in that table immediately. I'll be right back. All right. This is the table in question. Okay. I want to show you the details. This table, each box has what? About nine key facts. This is the atomic number, mass or relative molecular mass, the name, the symbol, the name, the boiling point, melting point, the electronic configuration, especially when you come. This is the distribution of electron in the cobalt 28152. When it is above 20 elements, you might not know what to do again. This is phosphorus, arsenic is 28185. Then when you come here, this is the electronic configuration of all the elements, starting from hydrogen to organesium. Okay, when you go down, you will get this detailed information. And then this grouped element very well. You see the beautiful coloration. Look at the key. Tells you the metalloids, the halogens, the lanthanides, the actinides, the p block, transition metals, the alkali earth metal, and over here it shows the pair that are diagonally related. Diagonal relationship is clearly shown, and there is what we call the amphoteric line or the staircase. Very colorful and well designed. Then here you see the information about the periodic table, the long periods, the short periods. So this was actually designed by Majestic Sa Majesty. Here is where you place the name of your school in case. Then, funny enough, if you come here, you can now see how European called these periods. How come you have the IPAC recommendation? I have a detailed package where I unbox this table. Look at your half bar, the order of filling, the shells, and the maximum electron each shell can hold. The majestic periodic table is more detailed. Then the name of each group, the alkaline earth metal, use this in your laboratory. I'm very sure your student will be thankful to you. The halogens, the chalcogens, which you don't know about. So each family has its name. Now, I'm glad having you for this live stream. Thank you guys. Best of luck in your exams, of course. If your questions are not forthcoming again, I think it's time we say good night and best of luck. I repeat, this live stream is to help you, to prepare you. So whatever you see looking like this is just nothing but a clickbait. But guess what? If you are falling for the clickbait, you won't regret it, because the live stream covered exactly what you will write tomorrow, though not 100%, but likely questions, okay, that you will encounter. This is your salt analysis, and this is your titration question, which I've solved A. If you know the way I solved the A, you can also solve for the B. The first one, this is the first one I did. I used my table. Remember, your endpoints depends on what your school decides to use. Good night. Take care of yourself. See you after the exam, where we'll come back here and testify, then celebrate together.